Okay, so today we're going to look at compositions of congruence transformations. Now, that sounds pretty tricky, but really all I am saying here, compositions just meaning, doing more than basically one, so multiple. So it's just really meaning multiple transformations that result in congruent figures. So the same exact figure. Okay, so not just similar figures. So in other words, these will be multiple transformations that in order, okay, and that's kind of also useful. There's going to be an order to them that will result in a congruent figure, not necessarily the same exact figure. So in a different position. So these will be translations or reflections or rotations only. So there is a fourth type of transformation we're going to do this year that does not result, that as soon as you apply that transformation, it's called the dilation. It results in similar figures, but those similar figures are not congruent. These result in both similar and congruent figures, and like my new nails. So you'll see what I mean when we do them. They're kind of, one transformation into another. So basically the only rule is that, your start is the first one, so the pre-image is denoted. So let's say it's ABC. So notice it doesn't have any little prime values there. Then the first result is called the image, and it will be denoted A prime, B prime, C prime, like that. So we talked about that. Now, the first result, when you do compositions of transformations of any sort, you take the first result to get the second result. So you use this result to do the new. So second transformation happens on the first one. So the new image. Okay, and then you would call it something like A double prime, B double prime, C double prime. So this is if it were a triangle and you had that triangle ABC image, and this is still just another image. Okay. It's just that, like, kind of on that new transformation, this becomes the pre and this becomes the image. Don't worry too much about that terminology. Just kind of realize the most important thing that you realize is that this is the one you start with once you come to your second transformation, or whatever it may be. Okay, and for now, we're just going to do congruence transformations because we haven't learned dilations yet. Okay, so moving kind of to this first example. Okay, so example 1 is going to be triangle XYZ, which is not there yet. So triangle XYZ, which is 2, 1, 6, 1, and 4, 4. So I'm going to kind of try to sort of quickly graph this. So there's X at 2, 1. Okay, Y is at 6, 1. And Z, which is at 4, 4. So right here. Okay, so that's my original figure, and I'm going to use a ruler because if it's a possibility, it's always, for me at least, easier to use something that helps me draw a straight line. It's not really a skill that I have, and I wanted to go into neurosurgery when I was in middle school, so I'm sure I would have figured out a way. Okay, so that's the original image. So you'll see that it says now on the graph, draw the image of triangle XYZ after a translation of 2 to the left. So that's in this direction. That's the X minus 2, or you could have written it as, X goes to X minus 2. Normally we don't write it quite like that. It would be coordinates. So anyway, so this one will go here. Okay, so now that new image is going to be X prime, Y prime, Z prime. So here's 2 to the left, here's X prime, and I like to use multiple colors. It helps me to really see where things are. This is 2 to the left. That is y prime. Okay, and this one is 2 to the left. This one is z prime. So these will be, they should be congruent images because this is a congruent transformation. I just moved the figure over. A lot of times you'll see questions asked, and you'll see it in this one where it asks if the thing is congruent or similar. Technically, this is both, but what they're looking for is that you say it's congruent, but it's kind of both. It's both similar and congruent at this point. But what they're looking for is congruent, that it's exactly the same, just moved over. Okay, now we're going to take that triangle. Okay, so now remember we are going to move the new triangle, and we're going to reflect this triangle over the x-axis is what it says. So I'm thinking this looks kind of like a yellow. So we're going to reflect it over this axis here. So remember, we kind of just look at that here. This pre-image or the prime one is up 1, so the new one will be down 1. X double prime will be down 1. Okay. This y prime was up 1 here from the x-axis, so now it'll be down 1. So y double prime. Okay, and z prime was 1, 2, 3, 4 up, from the x-axis. So 1, 2, 3, 4 down from the x-axis, and here's z double prime. And then I'll just draw that as well. Okay, and so this is my new final image, kind of, and it should also, if it's been drawn well, I didn't draw it perfectly there, but it should be, this final image should be congruent. It is also similar, of course, but specifically it is, and then more specifically, kind of like the square rectangle. It's a very specific figure, and it's congruent to both of those figures, so not just similar. Okay, so that's a congruence transformation. That's a series of congruence transformations, so that was a composite congruence transformation. All right, so we're going to do some more. Kind of once you're comfortable, I am perfectly fine, of course, and anytime you can kind of stop watching these, or fast forward through, or however you like. So this quadrilateral, so this second one we're starting with, it's already on there. So the original image is already there. Now, this is going to be a series of 2 translations, so it doesn't have to be different transformations that you're using. So, and I'm only doing any series of 2. You could certainly have 3, but I'm only going to do examples with 2 for now. Okay, so the first translation is 3 units to the left and 4 down. Okay, so I'm going to draw that. That's going to be the prime quadrilateral. Okay, and 3 units to the left and 4 down. Okay, so here we go. 1, 2, 3. 1, 2, 3, 4. Okay, so that's R prime. Okay, and then S, 1, 2, 3. 1, 2, 3, 4. S prime. Okay, 1, 2, 3. 1, 2, 3, 4. P prime. And then Q, the last one, 1, 2, 3. 1, 2, 3, 4. Q prime. And kind of when I'm checking it, when I'm looking at it, I'm kind of looking and making sure are they at the same relative position compared to the other letters in the original figure. So like our P and Q just across like that. So that's another way you can kind of look at it. Certainly, if you figured out other strategies for doing this, there are definitely quite a few different strategies. Just certainly since we're kind of not discussing and coming up with multiple strategies right now, I'm just showing you one. Ooh, yeah, actually that looks okay. It just doesn't look as, my line here was not super good. So there you go. It kind of doesn't look congruent, but it should be. So, all right, so now I'm going to take this figure. So let's not worry too much about it because, I mean, we know that at least the points, and whenever I'm looking at it, I'm only going to be looking at the points to make sure the points are good. So we're going to take this and we're going to create the second, we're going to do the second translation here, taking this now new pre-image, but this second figure, and translating it using this rule. So x plus 2, y plus 1. So we're going to be over 2 and up 1. Okay? So that's going to be like kind of the last one, and then we'll have our final. I'm thinking we're going to find the coordinates. So over 2 and up 1. To the right 2, up 1. So 1, 2, 1. So there's q double prime. Okay, 1, 2, 1. P double prime. Okay, 1, 2, 1. S double prime. And then 1, 2, 1. R double prime. Okay, and then I'm going to connect these. Now, I'll be honest with these. I tend to be pretty careful with my steps. This is something that I find when I rush it, and this is something I didn't really like doing when I was younger because I rushed too much and I wanted to finish my work so quickly that I sometimes would mess one up. And of course, unfortunately, if one goes wrong, the whole series goes wrong. But we're not going to do any that have like major series of transformations. So this final one, which actually looks better than this one here, is my final answer. And it asks what are the coordinates of q double prime. And in this case, it was 3, 0. So x is 3 and y is 0. So it got moved right here. So that kind of final coordinates of the image, P, Q, R, S double prime. All right, 2 more examples, but again, if you feel like you're comfortable, I'm going to try to do some examples with rotations now. And one kind of example where it shows that order can, in some cases, matter just depending on the transformation. So sometimes it matters which one you do first, sometimes it does not. Okay, so here's the third example. Sorry about that. Okay, so that's just kind of my note as to what I was wanting to do. All right, so here's my original figure, A, B, C, D, okay? And the first thing I'm going to do, so I'm going to kind of just write up here what my two transformations are going to be. I'm going to reflect this over x equals 1 first. Whoop, sorry, you can't see that. There you go. Reflect over x equals 1, and then rotate that 180 degrees. And I didn't say clockwise or counterclockwise because hopefully you recall that with rotating, it doesn't matter if you're going clockwise or counterclockwise, you're going to end up in the same spot. Okay, so the first thing I'm going to do in order, I'm going to reflect this over x equals 1. Okay, so I'm going to draw that line where x equals 1. So this is the line x equals 1 up and down, and I kind of draw it with a dash. You can certainly just draw that and leave it there if that helps. For me, this helps to kind of figure out where I'm looking. Okay, so that's the line x equals 1. And this is 2 over to the right. So if I'm reflecting it over, whoops, excuse me again. Sorry about that. Over x equals 1, I'm going to have to reflect it to the left then. Okay, so remember, it's kind of like a flip. So this was 2 over here, so 1, 2 here. So D prime. Okay, this one, this C is 1, 2, 3, 4, 5, 6, 7 over to the right. So I'm going to count 1, 2, 3, 4, 5, 6, 7 over to the left. So that's C prime. Okay, then I'm going to do A. So A was 1, 2, 3, 4 to the right. So 1, 2, 3, 4 to the left for A prime. Okay, and then B. Okay, remember A was 4, so again, then 5, 6, 7, 8, 9 to the left, to the right, excuse me, and then this will go 9 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So again, I like to take my time on these because I like to be able to make sure that I've gotten all my points correct, particularly in ones where you're reflecting and rotating and not just translating, because I think translations are a little bit simpler. Okay, so, and I'll just draw, like kind of connect my figure, and then I'm going to rotate it. Okay, and remember, the kind of default, and pretty much all the time, unless for some reason you're instructed differently, the default is that once you've done one thing, you use the new image, the new figure to do the next thing. So you always start with the new one, not the original. Okay, so you're going to rotate this 180 degrees. Now, I personally very much prefer just actually turning the paper at 180 degrees, but whatever works for you is fine. So I'm going to go I'll go clockwise. Okay, so I'm going to go 90 and 180. And personally, I like to then kind of write what those points are. So I'm going to, up here, with nice bright orange, I'm going to write what my new points are. So my new A double prime here would be right here. So it is right there. So it looks like it's over 3 and down 6. So that A double prime is at 3, -6. Okay. And then I guess I'll look at B double prime just to kind of try to keep it in order. Okay, so it looks like if I look at B double prime, it's over to 8 and down again to -6. So down 6. So 8, -6 like that. Okay. And then C double prime up here is going to be over to 6, it looks like. Remember, this used to be negative, but now it's a positive because it's going to the right in the positive x direction. Okay, so that's 6 and then down 1. So that's going to be 6, -1. Okay, and the very last D double prime is going to go over 1, so +1, and then down to -1. Okay, so +1, -1. Okay, so here are my new coordinates, and what I'm actually then going to do is actually graph those 4 coordinates. So I'm going to kind of move it over so you can see that. So I'm going to graph that 3, -6, so over to 3, down to 6, and that was my A double prime, and then my B double prime is over to 8, down to 6, my C double prime is over to 6, down to 1. Okay. And my D double prime is over to 1, down to 1, right here, kind of on that original axis that I used for my reflection. All right, and so then I will graph that. My image should be congruent because these are all congruence transformations, excuse me. And for the most part, it should be. And then that is my final image after the series of, or the composition of those 2 transformations. Okay, so there's my reflection and then a rotation. So there's that one. And we're going to do one more example. And this one is going to kind of show the kind of if I'm doing things in 2 different orders. So am I going to get the same final image if I specifically, in this case, do a rotation, then a reflection, and then on the other one, a reflection, then a rotation. So the first thing is counterclockwise, rotate this about the origin. They're all going to be about the origin, of course. Okay, so our ST then gets rotated counterclockwise. So that's, I just went counterclockwise 90 degrees. So there's my image, and I'm just going to kind of quickly write R prime, S prime, T prime. Kind of take a little bit of time here. So R prime would be -4, so down 4 and down another, so left 4, excuse me, and down 4. So R prime is -4, -4. S prime is -3, -2. And T prime is -1, -3. Okay, this is my still favorite way to do these, is to turn them and move them around. So then I will now graph that image. So -4, -4, so R prime is right here. Ooh, sorry. I'll pretend I didn't draw that. There we go. R prime is right there. Okay, S prime is -3, -2, so I'll be fine on this one. And then T prime is -1, -3, so right here. Okay, so this is the first drawing of that with a rotation of 90 degrees counterclockwise. Okay, just ignoring the fact that I counted to 3 the first time and did not put that quite in the right spot. All right, so there is my rotated image, and kind of just to double check, just make sure it looks the same. Yep, that image looks the same as what I have here. Okay, now I'm going to reflect this across. I prefer to see across the x-axis rather than in the, but I've seen some people say in the. Okay, so across the x-axis. Okay, so now I'm going to like flip that image across the x-axis here. Okay, so that is going to be, and it's going to kind of get on top of the original image here. Actually, let's change this to the y-axis so you can see it a little bit more easily. It will have the same kind of conclusion. So we're going to do it across the y just because it's going to be much more easy to draw. Okay, so here I'm going to have T double prime, and then this is 1, 2, 3, 4 over, 1, 2, 3, 4 over, so R double prime, and 1, 2, 3, 1, 2, 3, okay, that's double prime, okay, so this is the final image there. Okay, so that is the second image after the first the rotation and then the reflection. Now I'm going to switch the order, but of course I'm going to change this to over the y. Okay, just in order to like, I mean, it's still going to go on top of each other, but maybe not quite as badly. Okay, so this one I'm going to first reflect over the y, and then I'm going to go 90 degrees counterclockwise. Okay, so first reflecting over the y-axis here. Okay, so this is 2 over, so I'm going to go 2 over here. So that S prime. 3 over, 1, 2, 3 over here. T prime. And this one's 4 over from the y-axis. So 1, 2, 3, 4 over from the y-axis. Okay. So here's my original reflection. Remember that kind of flip over the axis. Ooh, not the best line there, but again, I'm not really as concerned about that as I am where the points ended up going. Okay, and so there's my original reflection, and now I'm going to take those 3 points and I'm going to rotate this image 90 degrees counterclockwise. So I'm now going to, yeah, that's good. Okay, so I'm going to go 90 degrees counterclockwise. So I'm going to turn it this counterclockwise direction. There we go. And my R double prime is right here. So it's a -4, +4. Like I said, it is going to be kind of on top of the original image, but S double prime here will be at -3, +2. And then the T double prime is going to be over at -1, +3. Okay? So I'm going to translate that image back. So -4, 4, -3, 2, and -1, 3. So -4, 4. Oh, look, it's right on the original. So, let me make doubly sure that I actually did that correctly. -4, 4. Yep, right on the original. Yep. Oh, that's fine. Sorry. All right. So R double prime is going to be right on the original there. And then S double prime is at -3, 1, 2, 3, up 1, 2. So here's S double prime. Okay. And at -1, 3. So -1, up 1, 2, 3. Sorry about that. Got myself a little confused, like I said. Sometimes this is not my strength, but you'll notice here's my new image. The final image of the double prime triangle. Okay, so you'll notice that these are nowhere near each other. So the answer is that are these the same? No, they're not. Okay, so flipping the order does matter in some composite transformations. Okay, that doesn't mean that it's always going to. Okay, 2 translations in a row, it won't. But in certain composite transformations, the order can matter just like that. So you ended up with a very different final. Here's the final for this one, and the final for this one is up here, even on top of the original. All right, hopefully that helps with some understanding of just kind of putting some of these transformations together. And the practice is going to be for the next couple of days doing both IXL practice and or maybe not both, doing one or the other of IXL practice or the attached work. All right, everyone, have a great day and a great weekend, because I think this will actually head into Tuesday of next week. Have a good one. Bye.